Hello everyone, my name is Shaun Levick from the Geospatial Ecology and Remote Sensing Lab. Welcome to our next course on environmental monitoring and modeling. Today we're going to get started with Lab 1, which provides an introduction to the Google Earth Engine processing environment. I'd like to start by acknowledging the Google Earth Engine team, as well as the Earth Engine beginning curriculum that they provide to get you started with Earth Engine. Now the prerequisites for today is that you sign up for a Google Earth Engine account. If you haven't done so already, please do so now. This is the URL, earthengine.google.com/new signup. Now, Google Earth Engine uses the JavaScript programming language. We will cover the very basics of this during the course, but if you want to read through more detail, you can cover introduction provided over here. Now, if you're viewing this on YouTube, you can find this website at geospatialecology.com, and we're currently working through Environmental Monitoring Lab 1. The objective of this lab is to give you an introduction to the Earth Engine processing environment. By the end of the exercise, you will be able to search, find, and visualize a broad range of remotely sensed data sets. For today, we will focus on Sentinel-2 for the first exercise and learn to display imagery as true color and false color composites. We'll also learn how to calculate NDVI from multispectral imagery. So for today, we're going to be using Sentinel-2 imagery, learning how to search for and find cloud-free imagery. Sentinel-2 is a wide swath, high-resolution, multispectral imaging mission supporting land monitoring studies under the Copernicus program. It was developed and operated by the European Space Agency and has been sending data back to Earth since the 23rd of June 2015. Sentinel-2 imagery contains 13 spectral bands representing top-of-atmosphere reflectance scaled by 10,000. We'll start today by loading up a Sentinel-2 scene over Darwin, Australia, to see what it looks like in the Earth Engine environment. To get started, I'd like you to navigate to this URL, https://code.earthengine.google.com. Once you navigate to here, you will see that the Earth Engine environment is split into 4 separate parts. These are numbered over here, 1, 2, 3, and 4. Up here in the left-hand corner, we have a place for our scripts. Those are the scripts that we're going to write, as well as some example scripts that Google provide. We also have a tab for all the documentation, details on different methods and algorithms. This central piece here is for actually writing our scripts. That's where we have a section for new scripts, and we can run and save our operations. This box on the right is where the console is housed. That's where we can get some feedback if we're printing tables or charts. We also have an interactive inspector, and we have a tab for tasks if we are exporting imagery to Google Drive, for example. You'll all be familiar with the large map window, very Google Maps-like. A lot of the same features. We have the option of flicking between a satellite-based map and a standard map, as well as a terrain map underneath. Over on the left-hand side, we have our zoom tools, our hand tool, and a few geometry operators. Now we'll get started today by searching for the city of Darwin. We're based in Darwin, Australia. So I'm going to type in Darwin, and you'll see that a number of places pop up. We'll click on Darwin NT, Northern Territory, Australia, and our map will zoom to that location. Now, you'll see that I've provided some screenshots here, so you can either work through the tutorial or go along with the video. Our next step is to use the geometry tool to make a point on the Casuarina campus of Charles Darwin University. Once you create the geometry point, you'll see it added to the coding panel as a variable under the Imports heading. If I come back to Earth Engine, I'm going to come down here where I mentioned we had the geometry tools. I'm going to click on this little teardrop, and you'll see that we're now in a point drawing mode. I'm going to zoom in a little bit, and this is Rapid Creek and the suburb of Brinken. Charles Darwin University is located over here. So I'm going to click that map, and you'll see that under the import section over here, we've created a variable called geometry by default, and these are the coordinates of that point. I'm going to click on geometry and just rename it campus, and we'll use that reference for the rest of this tutorial. Next, we're going to query the archive for Sentinel-2 imagery. We're going to do this by searching for Sentinel-2 in the search bar. In the results section, we will see that Sentinel-2 multispectral instrument level 1C pops up. So we'll go back here, and instead of searching for Darwin, we search for Sentinel-2, and you'll see that there's actually now two options within the Google catalog. We have the level 1C data and the level 2A data. The difference between these is in the level of processing, with level 2A being further down the processing chain, and you'll see that it is available since March 2017. So this level 2A already has some atmospheric corrections applied. However, we want to go back to slightly older imagery. We want the full Sentinel-2 archive. So we're going to work with level 1C data. This is top of atmosphere data. It hasn't been atmospherically corrected yet, but it is available from June 23, 2015, and the catalog is usually up to date within a week of collection. So this little pop-up window is a nice way of learning about the different satellites. We have some background information. We can see the availability, the provider. We have information on the revisit interval, and we have details on the bands within the imagery, the resolutions, the spatial resolution, the wavelengths. I'm going to leave that for now, but before we close, I'm just going to click on the Import tab over here, and we'll see that we've now added another variable to our import section, and that this variable is called Image Collection, and it represents the Sentinel-2 multispectral instrument level 1C. For today, we're going to rename this Sent2 for Sentinel-2. Heading back to our tutorial, we're going to continue reading through here. It is important to understand that we have now added access to the full Sentinel-2 image collection. That's every image that has been collected to date to our script. Now we don't want to load up all of these images. We just want to find a single cloud-free image over Charles Darwin University. In order to do that, we're going to use some filtering commands to query that collection and pull out the image that we want. Now, in order to do that, we're going to use a bit of coding. In the JavaScript programming language, 2 forward slashes indicate comment lines and are ignored in actual processing steps. We use these double slashes to write notes to ourselves in our code, so that we and others who might want to use our code can understand why we have done certain things. Now, the way I've set this up in my website, geospatialecology.com, is that you're able to copy the code snippets out with this little icon on the right hand side here. So I want you to copy this piece of code You'll see it's copied to the clipboard and pasted in line 1. Now we'll talk a bit about what we're actually doing here. So this is our first line of code. Remember, everything that's in green now with these forward slashes is not going to be read by the processor. These are notes to ourselves. This first line, we're defining the image collection we are working with. And we're going to create a variable called image. So variable image is going to be equal to Earth Engine image, open bracket, send to. So what we're telling the processor is that we want our image to come from this image collection. See, this send to refers to this image collection. However, we don't want all images that have been collected. We're interested in images from a particular date range. So we use the command .filter date, and we input a start date and an end date that we are interested in. Now, be careful here in that we're using the year, month, day style of date writing. Filter date will filter by time window, but we also are only interested in images that intersect Charles Darwin University. So we add a next filter, .filter bounds, and be careful with your upper and lower cases here. Filter bounds, capital B, campus. And this campus, of course, refers to this point that we have made with these coordinates. Now, we've now told it which time interval we're interested in and which spatial location we're interested in. But we are also going to sort by cloud coverage assessment. Cloud coverage assessment is a metadata attribute in Sentinel-2 imagery which specifies the level of cloud cover. And by sorting by cloud coverage assessment, we are sorting the images in this date range that intersect our point from the least cloudy to the most cloudy. And since we generally want cloud-free imagery, we're going to ask Google to give us back the first image after it has been sorted. So that will be the least cloudy image. And after all that, we're going to print the image to the console. We're not actually viewing the image yet, but we're going to print details of the Sentinel-2 scene to the console over here. So when I hit run, Google will work its magic, and it will find us the image that intersects this point within our desired date range with the least cloud cover. And you'll see that details of that pop up here. Just going to move down here so we're all at the same place. Here we go. And you'll see that in the console now we have details of a Sentinel-2 scene. We can use the drop-down list to see some more information about it. We know that there are 16 bands, for example. And importantly, we can see the date. We know that this is the Copernicus collection, Sentinel-2. And from the date here, we can see that this image is from 2016, April the 10th. Heading back to our tutorial, we're now going to look at how to add images to the map view. We're going to start with a true color representation by pasting the following lines below the ones you've already added and clicking Run. So we'll copy this piece of code out, paste it in, and we'll see that the first thing we're doing is defining some visualization parameters in a JavaScript dictionary for true color rendering. Now remember that for a true color image, we need to provide an RGB composite, red, green, and blue. And if we go back to looking at this Sentinel-2 little band table, we can see that band 2 represents the blue wavelengths, band 3 the green, and band 4 the red. So if we want an RGB composite, we need to make use of bands 4, 3, and 2. And we're going to specify a minimum value of 0 and 3000 for the reflectance values. And these are a good range for Sentinel-2 imagery. If you're working with Landsat, that'll generally be in the range of 0 to 0.3 or 0.4. Now this next line here will actually add the image to the map using these visualization parameters. And the command for that is map.addLayer. And again, be careful with your use of upper and lower cases here. Map.addLayer image. This image refers to this image here, which is the one from this date. So we're asking it to display our image using true color visualization, which we've defined over here, and to call this layer true color image. This bit over here is what the layer name will be. And what I mean by that is when we click run, we'll run through the script again, and you'll see that in our layers tab over here, we now have a true color image popping up. And what you're seeing displayed on the screen now is a true color image collected over Darwin on this particular date. We zoom out a bit, you can get an idea of the spatial extent of a Sentinel-2 image. You can see it's a very interesting landscape up here in the north of Australia. We have the coast, of course, the Tiwi Islands lying to the north, and some really big, large floodplain rivers draining northwards. And at this time of year, end of the wet season, you can see sediment being delivered to the coastal regions. Now, our next step is to play around a bit with the imagery, get used to the environment. You can use your hand tool to navigate. You can use the mouse wheel to zoom in and out. You can also play with things like transparency by adjusting this little slider over here. Now, one of the really great things about this type of setup is that we can click on this point here. If you click it once, it becomes active. You can then click and drag. So if we now decide actually we wanted our image somewhere over here, all we have to do is drop the pin there, click run again, and we'll query the archive. You'll see it's found us a different image now from 2015, August, and that'll pop up over here. So it's a very versatile tool. I'm going to bring that back to Charles Darwin University and just click run so that we're all in the same place. Heading back to the tutorial, our next step is going to be to define a false color visualization parameters. What I mean by false color is that instead of looking at a true color representation, we're going to make use of band 8, band 8 being the near infrared band. So instead of using red, green, and blue, we're going to use near infrared, red, and green. And just to show you this table again, band 3 is green, band 4 is red, and band 8 is the near infrared. Remember that if you're working with different sensors, like Landsat for example, then band 5 is near infrared and not band 8. Same story again, map add layer image, but this time using false color, and we're going to call that layer false color composite. When I click run, we'll now have two layers coming up over here. First, the true color image will load. Just zoom in a little bit. Here's the true color image. And now here comes the false color on top. The false color really accentuating the green photosynthetically active vegetation. Okay, that brings us to the next point, and that these, just by visualizing different color combinations, can be very powerful, but sometimes we want to be more quantitative and derive indices from band combinations. And in terms of vegetation monitoring, quite a common one is the normalized difference vegetation index, which is an index that explores the ratio of the near infrared to red bands. So we're really looking at absorption and reflectance of solar radiation by plant leaves that are actively photosynthesizing. So the equation to calculate NDVI is near infrared minus red divided by near infrared plus red. Now this looks a little clumsy at first, but it's actually quite a useful way of defining equations in Earth Engine. So we're going to copy that to the clipboard, come back here, paste it in, and you'll see that we are defining the variable NDVI from our equation. And the syntax for that variable NDVI equals image.expression. And then within these brackets, we put in our actual equation, near infrared minus red divided by near infrared plus red. However, Google's processor isn't going to know what near infrared and red is in this case. So within the curly brackets, we're going to define these. We're going to say that red is band 4 from our image. So image.select band 4. Near infrared is image.select band 8. And blue, although we're not using it, image.select band 2. So this is where we define what this is referring to. So we're telling it that it needs to pull out a particular band and do the maths on these certain bands. After it's done that, we can then, so now that we've defined what NDVI is, we can then map it out spatially using map.addLayer NDVI. And NDVI will range from -1 to 1, and we're going to call that NDVI. When I click run, we'll see now that we have 3 layers popping up, with the NDVI being the last one. So you'll see that the water shows up as pure black, and over land, all the bright areas are where we have actively photosynthesizing vegetation. That's more vigorous vegetation. So this is great, but the color scale is a little boring. If we want to add a more interesting color scale, copy in this next piece of code and paste it into our script. Map add layer NDVI min 0 max 1. But the new thing we've added is that in our visualization parameters, we've defined a palette to be scaled from brown through yellow to green. And we're going to call this layer NDVI color. When I hit run, we'll see that we're now loading up 4 different layers. And this can sometimes take a little bit of time. So another little trick is that if we come back up here to where we're adding our true colors and our false colors, we can just add in a little command here, just specifying false. So when I run this again and go back to layers, you'll see that these are automatically unticked. So if we write false in here, we're telling it not to automatically load that layer. They're still in our layers tab, and we can call on them if we want to, but if we're mostly interested in the NDVI, we don't have to waste time waiting for other images to load up. So coming back to our NDVI image, I said that we would use this palette, and that does look a little bit more interesting, although water really shouldn't be brown. If we want to add another color, we can simply type in blue, for example. Remember to put a comma between the colors and check that they are all within the little quotations. If I hit run again, we will still have our 4 layers, only 2 of them will be active, and now we'll see that the blue is given to the water. We don't have a lot of vegetation here reaching that really max near 1. Also, another point to make is that if we want to query the actual value, we can do that in the Inspector tab by clicking on a particular point. We can see the spectral response across our imagery, and we can see the NDVI value for that particular point. And the last thing to end off with is just again a note that if you're interested in a completely different part of the world, you can just click and drag that little marker wherever you are, hit run, and this will pull up a cloud-free Sentinel-2 image for a given date range and map NDVI across the landscape. So thanks very much for your attention. Remember to please come back to the Gears lab. This is lab 1 of 10 in this series. So I'm Shaun Levick. Thanks very much for your time. Cheers.